Alright, sorry about that, ladies and gentlemen. Tried to make that time, just barely didn't make it. So let's wrap up here. We're almost done. Continuing with parent functions. So exponential functions. F of x equals b to the x. Now, we can tell really easily how it's exponential, right? Because x is in the exponent. That's how we're going to tell that it's exponential. Now, we also notice that we have a base here, a b. For example, we're going to use 2 to the x. And let's see what happens when we plug in our numbers. So 2 to the negative 4. If we know our rules, that gives us 1 over 2 to the 4, which equals 1 over 16. Negative 2 is 2 to the negative 2 equals 1 over 2 squared equals 1/4. Next it will give us 2 to the 0. We know that 2 to the 0 equals, well, anything to the 0 power equals 1. Then we'll have 2 squared. 2 squared we know equals 4. And then 2 to the 4th is 16. If we look at how this is going to graph, well, at negative 4, 2, 3, 4, we're at 116. That's close enough, right? At negative 2, we're at 1/4, so just a little bit above that. At 0, we're at 1. At 2, we're at 4. And then at 4, we're way up here at 16 somewhere. So let me see if I could do this better this time around. So if I draw this, much better. Awesome. We could see as we increase to the by x on the same increment, y increases drastically. So if we go from 0 to 2, we only increase 1, 2, 3 units. But if we go from 2 to 4, we increase another 12 units. So, and then if we went from 4 to 6, it would increase a lot more than that. So this is our exponential graph. You can also maybe see it as an exponential decay. It looks similar, just reflected across the y-axis. So this would be the decay and growth. Here's an actual question for exponential growth and decay. The amount of leaves that fall off a tree each day doubled. How many leaves fall after 14 days? Well, if it doubles each day, right? Oops, shoot, so I did it again. Here we go. Alright, so if it doubles, we have a base 2 after how many days? So, 2 to the 14 equals, I'll let you figure that out, and I will ask you on the questions. Alright, so here's something that you might have to do. Match the function with its name. So linear, it's just x. X by itself or a combination of x, so will be linear. So we go right there. Now, if we have x, what's this? Well, it's going to be the reciprocal, right? X is on the denominator somewhere, it's a reciprocal. That's how you remember that. X in the denominator, it's a reciprocal function. Now, this one's pretty simple, right? It's the one that has the sign, it's the name of it, square root, square root. Now, what does this do again? What function is this? The only one with the bars? Absolute value. Now remember, the graph of absolute value also looks like a V. So absolute value, graph of a V. Alright, x squared, or how else do we call this? Quadratic, right? Squared will be quadratic always. Now that's only if squared is the highest exponent there. If it was the third, maybe, what would that be? Well, cubic. And then x is in the exponent, therefore it is exponential. Some other examples of things that you might see or ask questions about. It'll say So you might get something like that, and they'll say, what is the parent function? Well, we should know it's square root of x, right? There's a square root in the equation. Well, then the parent function is square root of x. What's this parent function? Well, it's the only one that has, vertical bars, right? Absolute value. Absolute value is its parent function. So you'll see stuff like that. You might also see an equation such as, let me think of one. Something like this, 2x cubed minus 3, and they'll say, show the graph of the parent function. So if you know that this is a cubic function, why? Because 3 is in the exponent, so cubic, then you should just know the graph of a cubic function. It was kind of like that, right? So those are some of the examples of type of questions you'll see. All right, excuse me. I'll let y'all get going. Have a good night. Go Texans.